So a few weeks back, a tremor shook Southern California. And it was that familiar jolt, a little reminder of the powerful ground that's always moving beneath our feet. But what if I told you that the science we use to understand that little quake is the exact same science we're now using to listen for the most violent, most extreme events in the entire universe? Yeah, it's this incredible connection that stretches from our own backyards to the very fabric of space-time itself.
And it all starts right here, with a really human experience. This was a real post from somebody in Orange, California, just moments after the shaking started. It just perfectly captures that immediate, personal feeling we all get when the solid ground suddenly, well, isn't so solid anymore.
Pretty soon after, the official number came in from the U.S. Geological Survey, a magnitude 4.9. Now that's not a monster quake, not by California standards anyway, but it was definitely big enough to get everyone's attention.
So this is where our story really kicks off, with that one jolt. A single moment that, for just a few seconds, connected millions of people across a huge part of the state.
Okay, so here's the rundown. The quake was centered near Indio Hills, but get this, it was incredibly shallow, only 2 miles deep. And that's the main reason it was felt so widely, all the way from the Coachella Valley to LA and even San Diego. For most people, it just meant some stuff falling off shelves, a whole bunch of phone alerts going off at once, and then a few smaller aftershocks. But here's the crucial takeaway. No major damage. It was basically just a good scare. But that scare is actually a really valuable reminder of the science of scale. So let's zoom out a bit from that personal experience and really understand what happens when these numbers get just a little bit bigger. To really get what's at stake here, just consider this. A few weeks before that California quake, a magnitude 6.5 earthquake hit Guerrero, Mexico. Now on paper, 6.5, it doesn't sound that much bigger than 4.9, right? But the energy released is it's on a whole other level. The 4.9 quake was a regional scare. The 6.5 was a fatal disaster that damaged over 5,000 homes. That is the absolutely terrifying power of the magnitude scale.
So, what's the engine that's driving these massive events? Well, it's a process called tectonic subduction. The easiest way to think about it is to imagine one colossal plate of the Earth's crust slowly, relentlessly grinding underneath another one. And as it does that, it builds up stress, like a giant coiled spring, for decades, sometimes even centuries. And when that spring finally snaps, that's when you get a catastrophic earthquake, like the one in Guerrero.
And all of this brings us to a really crucial question. We've gotten very, very good at measuring earthquakes after they happen. But what if we could find the hidden dangers before they break?
And that's exactly what seismologists are trying to do right now. The key, they're discovering, isn't to wait for that deafening roar of a major quake. No. It's to listen for the constant, tiny whispers of the earth. These are imperceptible microquakes that are happening all the time, and they literally light up the hidden faults beneath our feet, showing us exactly where the next big one might be built.
Okay, so hold on to that idea of listening for whispers. Really let that sink in, because we are about to scale it way, way up, from the crust of our little planet to the very fabric of the universe itself. Because it turns out the same fundamental challenge exists on a cosmic scale. It's absolutely wild. Instead of listening for microquakes in the Earth, astrophysicists are trying to hear the faintest possible tremors in space-time itself. These are called gravitational waves, and they're produced by things like colliding neutron stars, some of the most violent events we can possibly imagine. And this chart right here shows you the incredible leap we're about to make. So, look at that tiny bar on the far left. With our current technology, hearing one of these cosmic tremors is like a once-in-a-century event. It's incredibly rare. Now, look to the right. The next generation of detectors, like something called the Cosmic Explorer, will hear hundreds of them every single year. We are about to go from a tiny trickle of data to an absolute fire hose of cosmic whispers. So, how on earth are we going to listen to all of that? How can we possibly pick out these incredibly faint, important signals from all the background noise of the cosmos? Well, the answer is a brand new kind of tool, a highly advanced artificial intelligence. It's a special type of neural network that's been trained to do one single thing better than any human or any other program could ever hope to: listen to all that cosmic noise and pick out the faintest, most important signals. And its performance is, well, it's staggering. This chart basically measures how good the AI is at telling the difference between a real cosmic whisper and just random noise. A perfect score would be a straight line going up and then straight across. And as you can see, this AI is nearly perfect. In tests, it's 99.998% accurate. That means out of 100,000 signals, it might miss only 2. It's an almost flawless listener.
So where does this new AI fit into the picture? This table really shows you the trade-offs scientists used to face. Before, they had 2 choices. There was a super accurate method, but it was incredibly slow. It took about an hour for each event. Or there was a fast method, but it was really inaccurate. This AI creates a third, game-changing option. It hits this revolutionary sweet spot. It is unbelievably fast, analyzing an event in just 3 milliseconds, while staying remarkably accurate.
And just to put that speed into perspective for you, this new AI is more than 1.2 million times faster than the old high-precision methods. Let that sink in. It takes what used to be an hour of really complex computation and does it, quite literally, in the blink of an eye.
So, let's go back to that chart of the future for a second. Making that massive leap, going from a few detections to thousands, is only possible if you have a tool that can actually keep up. This AI isn't just some cool concept, it is the essential piece of infrastructure, the key that will finally unlock that data deluge. It's what's going to turn that flood of faint cosmic whispers into a beautiful symphony of new discoveries.
So, from a small tremor in California all the way to the echoes of colliding stars across the universe, we are building a whole new science of listening. A science that promises to reveal the hidden dangers right under our feet and unlock the deepest secrets of the cosmos. The only question left is, what will they tell us next?